Hello everyone, welcome to the video. Today I am going to be installing Arch on a Chromebook. It's as simple as that. This particular Chromebook came to me a few years ago from a friend who got it for free from some internet deal. Anyway, it's found its way to me, as most junk does. And to cut a long story short, I went through the process a few months ago of cracking it open, disabling its hardware lock, and installing a kind of a free BIOS on it, essentially, so it can be just treated like any other laptop. It's ended up kind of with my son now. It has, up until this point, been running Cosmic Desktop. I was using it as a bit of a kind of just to test it out, just to try out the alpha of the desktop. It's really not very well suited to the hardware. It's not well suited to the hard drive space either. It's 32 gigabytes on this thing. But it was enough for me to mess about with it and decide that I wanted to kind of play about with it on my main machine, which is what it's on now. But the laptop's with my son now. He will be installing various things, various games. Well, whatever games can actually run on this thing. Space basically is a premium. CPU resources is a premium, and RAM is a premium. RAM is four gigabytes of RAM, 1600 megahertz on the processor, and 32 gigabytes, as I've mentioned, on the MMC storage. Slow as all hell. So I want to be optimizing all of these things, and I've decided that in order to do that, for when it comes to performance, to make it as fast as possible, I'm just going to stick XFCE on it. It's probably my favorite of the kind of the classic lightweight desktops. Can't really tell you why. I just like it. I like its vibe. So that's what we're going to put on it. I'm going to. I know you can do this with the Arch install script, but I'm going to do a manual install, mainly because I just want to go through the process. Obviously, it makes a more interesting video. This isn't a tutorial by any means, so please don't treat this as a tutorial. This is more just join me in this comfy evening, past midnight at this point, as I install Arch Linux on a machine that would otherwise be e-waste, and breathe some new life into it. And every time you install Arch manually, you strengthen the synapses, you strengthen the connections in your brain, you get a little bit better at it, you get a little bit better at just Linux in general, I find. So let's do that. That is not to say that I have anything against the Arch install script, by the way. There's a separate rant about people that get snotty about that, that will probably come in a future video when I start getting a bit more opinionated. But right now, I'm being nice to everyone, so let's do that. Okay. Right, to start with, let me give you a better view. So I'll just set the font here to something much nicer. It's sarcastically large, especially on my screen. Right. So to get started, we will get into the interesting stuff of dealing with the disk and the decisions I'm making around the size of the boot partition shortly, because I'm going to be a little bit spicy with that. In fact, spicier than I intended before I even pressed record. So we'll see how that goes. But first, we just need to we need to let the installer know who we are. Just some, what our favorite color is, what language we like to type in, that sort of thing. So let's take a look at the key maps that we have available to us. There's a lot. So, if you're a Dvorak enjoyer, if you happen to have an Apple keyboard, if it's taking a break from being a doorstop, you can use that. But anyway, in this instance, we're in the UK. We don't have to do anything fancy, so we will just load keys UK, and this will load it in for our installer. We will have to do something very similar later on for our actual installation, so it remembers that we're in the UK and not in America or anything terrible like that. Next up, internet. Now I will have not Arch install, archlinux.org. So we'll just to prove we've got nothing here at all. We're on bare metal. We're not in a VM. There's I have a slight bugbear with Arch Linux installation videos that I've seen. I tend to watch quite a few of them. I think I might have a problem, but there tends to be this thing where they will say, okay, I'm using wired internet, or I'm using a VM, so it's already got internet. Basically, when you're installing, I highly recommend you use a wired connection and don't use Wi-Fi, and then they just skip over it and continue. And that's all well and good. It is better to have wired internet for sure. But this laptop doesn't have a wired port. And right now, all of its USB holes are filled because I have this cursed recording setup going on. So there would be no way for me to get wired internet on this. Wireless is important, and this is by far, I would say, probably, well, I'm guessing, but this is probably the thing that turns away most people from the Arch installation. It's the only thing that you kind of the only like really challenging thing you have to do before you run the Arch install script. So I imagine it's turned away a lot of people. And to be honest, I think the initial screen could do a lot better with describing this process. Anyway, rant over. The command we need is iwctl. I don't know what IW stands for. Internet WAN, maybe. So first off, in fact, the only thing really we need to find out before we run the main command here, we want to list devices. Oops, list device. See, this is my point. If it gave us a nice little TUI or something, there we go. Device list, WLAN 0. So most of the time, if you're dealing with Wi-Fi, that is exactly what your device will be called. But we need to know for sure. And the command is this: station WLAN 0. That is our station. Connect, and then you put in the SSID of your Wi-Fi, which you should know, to be perfectly honest, because you would have sought out your password at this point, I would hope, so you'd know what Wi-Fi network you want to connect to. But luckily as well, there's autocomplete here, so if I start typing the name, it loads it up nicely. Honeynet, named after my old dog, who I might flash up a picture of her because she was a good dog. So yeah, station WLAN 0, connect Honeynet, and then you put in your password. Now hopefully you have taken the time when you first got the internet to set up a password that you actually can keep in your brain and not one of those ones that they put on the card. It really does improve the quality of your life, like immeasurably, because you forget how often you're connecting things to the Wi-Fi. And if you actually know your password in your head and it's something you can actually remember, it really does make a difference. Oh my God, I can't type. This, like I say, this keyboard is unique. And there we go. That worked. It didn't. That utility is nice and everything, and like, you know, it's great. Wi-Fi over command line, whatever. But it's, you know, a bit more feedback would be nice. Like, oh yes, you've connected. Well done. Continue. Anyway, that's that part out of the way. The next part is to check the time zone. Like, this is in the installation guide. I'm not entirely sure what the point of it is. It might be that if you're not in this time zone, you have to then change it. But like, you set your time zone later, and I don't think it has any impact like on the install process. But I'm in UTC anyway. I am in the alpha time zone, the time zone that all of the time zones judge themselves against, the time zone that every time zone wishes it was, but it isn't. So that's good. We can just continue and get into the really good stuff, which is partitioning the disks. So I like to use CF disk because I do like me TUIs, because I still get a little bit scared with fully fully terminal apps, and we do need to tell it exactly which disk we're wanting to do this for. Now, I can use autocomplete here. So the name of the disk, in fact, let's do this properly, shall we? LSBLK, list block devices. We can ignore loop because I have no idea what it is. We can ignore SDA because that's our boot SSD, our install SSD. And this is what we're looking at here, MMC BLK1. That is the MMC storage in here. As you can see, it is very small. It's pathetic, to be perfectly honest. Like Chromebooks have this philosophy of like everything's on Chrome, everything's in the cloud, blah 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 blah. So it's basically an excuse to have as little storage as possible, because for whatever reason in the world of technology, storage seems to be like the most expensive, the most premium thing. Like, you know, if you get a phone with a little bit more storage, it's like hundreds of pounds more, but whatever. Okay, so CF disk. So we now know that the disk that we're interested in is MMC BLK1. MMC block 1. Marvelous. Right, so we have our existing partitions here because this is a functional system at the moment. But we're going to delete these. So move down, delete. And now we have our lovely free space. Pure as the driven snow. Now, okay, so the partition situation. I basically want as much storage as I possibly can have in the root partition, because as you can see, it's our premium. So I want to make the boot partition basically as optimized as possible space-wise. If you ran this through the Arch installer and did the recommended settings, it will give you 1 GB for your boot partition, which I think is really sensible in like most cases, because at the very least these days you'll have what, 256 gigs. There's two things here. One, we can have it less than 1 GB for sure. We could comfortably have it at 400 because the 150 for the stock kernels, plus some nice room for my custom kernel that I'm going to have to install on this in part 2 of this video. I'll explain more in that part, but basically this Chromebook needs a custom kernel. The Carina model, with the Stony Ridge chipset, AMD Stony Ridge chip, needs some patches into the AMD drivers to allow sound to work and to basically make the video part of things work better as well. So that's a whole process. There's a whole thing to do there. So I will be installing an extra kernel. But what I also want to do is get rid of the fallback, because at this point I've swapped out kernels quite a lot. I've got a fair bit of experience with it, and I believe I don't really need the fallback one. If anything terrible happens to this system, I cannot stress enough how little it matters. This thing should be in a landfill. My son is using it, but all of his files that go in his home directory are backed up all the time. They're backed up right now. Reinstalling stuff on this laptop is nothing. So I think like there is no risk, basically. There is zero risk. So I want to just get a bit spicy with it. So with that in mind, I think I could get away with 200 megabytes. So let's do that. Now, this is the reason I'm prevaricating here. This is a fairly important decision, because you can't just resize everything. Like if you change the start sector of a partition, it has to be deleted. Basically, it has to be formatted. So right, so there we go. Anyway, we've got our two partitions. We've got EFI. We've got Linux. We're not going to do a swap. I think swap automatically gets sorted out. There's a swap chip or whatever in here, something that deals with the swap side of things, I'm pretty sure. But again, we don't need it, so we'll just write write our new table and quit. And then if we list block devices, we can see there 200 megabytes. Oh, let's see how this goes. Right, so format time. So we make FS, so we will format the boot partition with FAT32. Good old FAT32. It's like, you know, coming over from Windows to Linux. You know, I'm looking around. I don't really know anyone. Bit awkward, you know. I've not met anyone, not a chance to socialise yet. And then I just see in the corner of the room, oh look, there's FAT32. I know him. I'll go and talk to him. Oh, it's not SDF. It's like just like an old friend. I didn't know he was over here with Linux. And then the root. Oh, this is a really bad way of doing this. The root partition needs to be extended 4. And this takes a shocking amount of time considering how small the drive is. Right, all good. Right, so we're ready to mount this. So we will mount these, mount both of these devices, basically so the installer can access them and copy all the stuff across that it needs. So to start with, I'll spell mount correctly. We want to mount MNC BLK1P2, that's our root, just to the mount folder. Then, now the mount folder is directly writing to that drive, I will add the boot folder. And then I will mount that to our boot partition. God, it's really quite intrusive, that autocomplete. Mount boot. Okay, we're basically, the next step is basically to run packstrap, which is the main install function, to get all of our packages, all of our base packages in there. First though, we're just going to sort our mirrors out. We'll use a program called Reflector, which exists on the boot, on the install system. It's something I think you need to install separately once you get into your system. But oops, I noticed actually, yeah, on my main machine. The only reason I mentioned this is on my main machine. I've noticed things started getting sluggish with Pac-Man. Doing update runs, like just things were just starting to slow down, and I'm not 100% sure if this was the case, but then I suddenly thought, oh, do you know what? I've neglected my mirrors all this time. I've just had whatever were the best mirrors at the time that I installed it, like months ago. And mirrors come and go. Some of them, you know, get slower. Some of them get faster. So I ran this today, and it seems to have pick things up a little bit. But basically, yeah, Reflector, we tell it United Kingdom, it will take, I believe, the 20 fastest ones and write that to our mirror list. I think we can test this theory out by cutting out XT Pac-Man D mirror list. Oops, fucking hell. Not Pac-Man S, Jesus. Pac-Man D. My favourite rapper, actually. And it doesn't look like that actually did what I expected it to do. I wonder whether that just gave me an output that do you know what I'm supposed to flipping do? Oh, I've got to pipe it, haven't I? Do I do this? Yes, I do this. etc Pac-Man D mirror list. Now when I cut that out, it's got the UK things. Okay, that's what you're supposed to do. Okay, so packstrap. K. K stands for something. Don't know what. We want to install to mount. That's our root drive. That's our system. We want base. We want base devil, which isn't included in the install guide, but I want this for AUR reasons. And then we want Linux because we want Linux, and we want Linux firmware because we want hardware to do things. And we also want Network Manager, mainly so I don't forget to install it later. And we want Vim, and we want Nano in case Vim decides it hates me. And I think that is all we need. So let's get that going. Now, yes, this may take some time. So 174 packages. Just thinking about it, what I said earlier about Reflector maybe speeding up my machine that I did today is clearly bollocks, right? Because I was doing it wrong. So that's a good example of placebo effect in action there. I will do that properly after recording this. This is why, by the way, that you shouldn't be taking this as a tutorial. We're just hanging out, don't have to make it, don't have to make it business-like and tutorially. It's a bit weird, isn't it? Last few bits. Oh, on the firmware, on the business end. Yes, I know you're possibly missing firmware for those things. I see it every time I boot this up. And one day I might look into that. There you go. There's the fallback image in the initramfs. That. I'm gonna kill that. I'm gonna see what happens. Okay, we're installed. Just one more thing to do before we Dwight Chroot in is we need to generate our fstab. Now I find this really impressive. We just point gen fstab at mount, and from that it just finds our two drives, all the information about it, and exports it all to the main fstab config. So yeah, seems good. Cat, just to check, because this is very important, because this is going to make sure that the that everything is mounted correctly at point of boot, maybe even before boot. Maybe the very first thing it has to do is to find the bootloader and everything. I also need to copy down this long UUID here that's just underneath the partition 2. This is going to be important for our bootloader config a little bit later on. Okay, now that that's done, we can chroot ourselves in. Change root. And we've got a handy little command for this. I do wonder, how you have these Arch install or anti-Arch install purists, like if you're using Arch Linux, you should be doing the manual install so you understand what you're doing. I wonder if they existed like years ago, right before Arch install, like with Arch Chroot. It's like, oh well, if you want to understand what you're doing, you need to do the normal Chroot command with all of the arguments, not run this Arch Chroot newbie nonsense. Worth thinking about, isn't it? Okay, that has basically changed our context. Essentially, we are now in our new install. If I was to list here, and we can see everything you would expect in a system, and this is our install. So we can go into boot, and we should see our lovely kernels. Oh, lovely kernels! Now this is when I'm going to. Now, do you know what worries me? This fallback is quite big, isn't it? Do you know what I'm going to do? I'm just going to rename it. Because when we configure our bootloader, we're not going to attach this to an entry. Oh yeah, idiot. Just forgetting how to do the most basic commands. That's good, isn't it? Okay. So, yeah, we're not going to be adding this to the bootloader, so nothing's going to be referencing that file. Now, if we can remove that, that's 124 megs? I guess it is. That gives us plenty of room. Lots and lots of room for our other kernel, and then we've basically optimized the size of that drive quite nicely. I'm sure. Let me just du. This gives us a rundown of the size of the. Nope, wrong directory. Apologies. So 174 right now. Yeah. So yeah, we're right up against the limit. I wonder how wise this was. Do you know what? I'm just going to remove it. Sorry. I didn't need to do the R thing there. I know that. Right. There we go. 55 meg. Beautiful. Okay. Now then, let's carry on and let's see how that goes for us. Right. Now we're starting to just get into the nitty-gritty of what our system needs to know about us. So once again, we need to tell it where we're from. This is the zone info. This will contain, I believe, all of the boring information about what our time zone is in relation to UTC. And obviously, we're in London. Our relation to well, not in London, but in the UK. Our relation to UTC is pretty straightforward. But zone info will say how many hours ahead or behind of UTC are you during standard time, during daylight savings, and importantly, which month and which week of the month do you change the clocks. So all systems have this information, so they know how to calculate what time at any particular zone is at any particular date in the year. If you're a web developer like me, you know that it's a pain in the arse. Okay, so we've set that. We've done a symbolic link there between the existing file, because all of the time zones exist on the system, because we kind of need to know about all time zones, possibly, but we're linking that through to our local time. And we can then generate, so hardware clock, I believe, HW clock. Do you know what? I actually haven't made a note about what this does, but I'm pretty sure it just makes sure that our internal clock is all correct based on that time zone that we have just set. Right, next up, localization files. This will basically decide what character set, I guess, we have, and maybe some translations for certain system strings. So we want to be editing the local gen file, and we want to search for ENGB. And just uncomment one of these. We'll uncomment the UTF-8 one. I like UTF-8. Quit. And then generate the locale based on that uncommented selection. Locale gen. There you go. So we found ENGB, UTF-8. It's generating all the shit. I don't know what it's generating. Something to do with languages. Next up, we have 3 very simple config files that we need to write to with some basic information. So the first one is related to what we've just done. We need to set what our language is. Now, the way I like to set up really simple one-liners like this is just to echo them, echo the value, and then write it into the file in one command rather than messing about with them. I'm not entirely sure whether it's quicker, but I just like to do it. So we want to copy that exactly as it is above there. So lang equals ENGB UTF-8, and we're copying that into etc locale conf. Excellent. Next one, key map. So this is the very first thing that we told the installer about. So our keyboard is the UK. We need this because we need to talk about pounds. vconsole.conf. Yep, that's good. And then finally, it's the host name. And this one is called Archbook because it is a Chromebook. It's a Chromebook no more, I should say. It is now an Archbook. Sorry, Google. There we go. They're written. Beautiful. Now, at this point, there is an option you can regenerate the init ramfs, and I think that's if you've got any funky configs or anything that you're kind of changing in the kernel, but we're not going to do that. Everything is fine. What we are going to do, though, is just sort our users out. So to start with, I'll just set the password for the root user. You ever have that worry that when you're setting a new password and it asks you for the new password and then to retype it, do you ever worry that you might have done a typo originally and then because of like short-term muscle memory, you do the exact same typo straight away again? It stresses me out. Maybe we need a third one. Like maybe after you've done the retype, it gives you like a 5 second. So say wait 5 seconds and flex your fingers, and then one more confirm, just to be 100% sure that you've got your password correct. Anyway, so now we've done that, while we're in the user mode, while we're thinking about users, let's add me. I need to be added. I demand recognition. So user add m will generate us a home directory for some reason. No idea why it's m. The group we want to be in is wheel. That's where the sudoers will live. The shell that we want is bin bash. Bin bash basic bitch. And username is Jonathan. For that is my name. Great, so I'm created there. Next up, we want to make sure that I am a sudoer. So a very dangerous file. In fact, I think this is so dangerous I have to put an exclamation mark at the end before I write to it. Basically, this line here we need to uncomment to let the system know that the wheel group is certainly allowed to sudo, but you have to put your password in. And then we will right quit, but exclamation mark. Marvelous. And finally, set my password. Because when we reboot, we will be logging in as me, because once the install's done, we will never use the root user again, because there's no need to. Right, so essentially our system is done. The root part of it, the root and boot partitions are all sorted. We now need to move on to the bootloader. The thorny issue of the bootloader. I am going to use the systemd bootloader. Now, there's a couple of reasons for this. Reason one, Grub, it senses weakness. If you approach Grub with fear in your heart, it senses it and it exploits it, and it will never ever do what you want it to do. And in my experience, very rarely have I had a positive interaction with Grub. Like if I'm installing something and it uses Grub and it installs it and does it all for me, it's fine. If I have to interact with it, if I have to approach it and look it in its eyes and ask it to do something, it will break. So I'm going to use the systemd bootloader essentially because I don't have that experience with it, because it's a lot simpler. It feels a lot simpler to me. Secondly, I know that systemd is thought of as bloatware. It is one of those. It's the new standard for init systems and all of that. It is the future, but the people hate it, and there's various distros that have been created just to avoid having systemd in it. Now, the reason for this is that it does loads of things, and it's against the Linux philosophy to do loads of things. You're supposed to do a few things very well, not loads of things, because it also does things like replaces cron tab. It actually hits home hard for me, that one, but still, my philosophy would be that if you do have you have something like systemd and it does a lot of things, then why not eat the whole cow? Like, use every part of it, or use as much of it as possible, because the more you use of it, the less it's bloat, because you're not installing grub, you're not installing cron tab or any of the other things that it manages a lot of things. You're not installing whatever you do for your services and whatnot. Yeah, so that's my flow. There's a few distros that I've seen that are kind of. Oh, I think there was the the GNOME distro wants to kind of like just systemd everything, and while that does sound a little bit cursed, I do appreciate the idea of like, you may as well embrace it, right? If you've got distros that are systemd nothing, you may as well have ones that are systemd everything, rather than halfway house. Anyway, that is a long way of saying bootctl install. What we need to do is edit two different conf files to point it to the kernel that we're going to be using for now to boot. Now, so to start with, we'll just edit the main bootloader conf. Sorry, it's loader.conf. Just to get some basic settings in here. I like having 5 seconds. The console mode is max. Editor no, and default is arch.conf. So we will be creating arch.conf. I'm just checking that, making sure everything's okay there. Yeah. So each of these conf files that we create. So if I go into boot, we go into the loader, and we go into the entries folder. So this is where we put all of the entries. So once we have a second kernel, we will create another file here. But for now, we will just have arch.conf for our default bootloader. This is, but basically the files that this is, so this is going to point to the default kernel files that we've got. They don't have any identifying names, they don't have version names or anything like that. They will get written over, I believe, every time Arch updates updates the kernel. So this entry will always be pointing to this freshest of fresh kernels. Once we create one, we'll be pointing it to a very specific kernel, which will never get refreshed unless we decide to. This is why I'm pretty confident now that having our super slimmed down bootloader is actually boot partition is actually going to probably work. So title Arch Linux, that's what we'll see on the bootloader itself. You won't see that because my capture situation won't show you it, but you'll get over it. VM Linux. One day I need to look up why it's called that. Is that how you spell his name in Swiss or whatever it is? Init rd. So then we point this to the init ram fs file. So this is this is the one of the fallback version of this is what we killed, but this is the regular one. So this is why I'm not worried, because we're not creating any in the Arch install. It tells you to create another conf entry for fallback, and I believe that is just if your install of the kernel goes wrong, you can boot off another one and then fix it. But we're not going to have that issue, because we're going to have our fixed in stone, Stony Ridge version of the kernel that won't ever get messed with anyway. So that is our fallback. So now we just need to point it to the root partition, and we copied down the UUID from earlier in the fstab file. So if you just bear with me, I will type this out. 4756844E3 A6EC 462C AF3C 0C 7F 903 7F 903 9 almost D709 read write. Okay, perfect. That is lovely. And no other typos that I can see there. It's okay. If there is any issues here, we simply reboot back into the install media, and we can access our drives and fix our problems, and then reboot again. And that's it. I believe we're ready to go. Ready to reboot. Just double checking everything. Okay, reboot. Ah, yes. We're in Chroot. If you're in Chroot, you cannot reboot. Put that on a t-shirt. Wear that t-shirt out about, and if you find anyone that gets it, then they can be your friend for life. Okay, the boot menu turned up, the option turned up. I've pressed enter, and it is booting. It has booted, and there you are on the screen. Oh, look, we've got the lovely errors. So this is a perfect example of why this Chromebook doesn't like the default kernel. These errors, I believe, they are all to do with the audio system. But pay no mind to such things, because I can still just log in as normal. We're in. Okay, there's one more thing to do, because if I pig archlinux.org, well, I mean, that will definitely fail, because that's not a URL, is it? There we go. It's failed. So we have lost our network settings that we set in our install. But this is why we installed Network Manager, and I will use the Network Manager TUI. No, I won't. Oh, that's because I need to start Network Manager. I definitely installed it, right? Okay, well, we'll soon find out. Systemctl will manage our services. We want to enable Network Manager with its capital letters. Okay, got no errors. That means we do have it installed. God, right, and start Network Manager. So now when we do Network Manager TUI, is it Network Manager -TUI? What is wrong with me? It's NM TUI. Jesus, right, okay. Activate connection. I'm not going to go with extensions. I don't trust the extensions. Oh God, hang on. It's late and getting passwords wrong now. Right, that should be good. This is a nice application. It actually gives you some feedback. So now when we ping, there we go. Beautiful. So now let us loose upon Pac-Man. There won't be any updates. Be weird if there was, right? They just like updated it. That'd be the most arch thing to do, like updated a package within the 5 minutes it took me to install and restart. So let's actually install some things. So I just want some basic tools here. wget, I don't tend to use, but it is, I like to know that it's there. Git, because we're going to need that to install Yay in a minute, which is our AUR helper. Xorg, because we need desktop. XFCE4, because we need desktop. LightDM, because we need to log into desktop. Technically, I could do that in the TTY, but this is for my son, so I won't subject him to that, don't worry. Then the greeter, so I believe the way this works is LightDM is the display manager. It's like the daemon. It's the thing that deals with everything. It's the service, and then the greeter is actually the pretty part. It's the interface, I believe. And Firefox, because once we're in there, we just need a browser, and then this is essentially all of the tools we're going to need to carry on with the setup, because obviously even when these are installed, this is not nearly enough stuff to to actually use the system in any real way. So pipewire jack. So we'll select pipewire jack, and what this should do is also add in all the pipe wires as a dependency, because even though our audio won't be working initially because of the kernel, it will be eventually. And pipewire also does other things. So GTK3, none of your GTK4s around here, sunshine. Right. Do you know what? While we're in here, before we go into the desktop environment, let's get Yay. So I like this. Installing a helper to help you with the AUR requires you to use the AUR properly just once. It's like an entry exam. So we just clone the Git repository from the AUR of Yay, which is our nice little helper. And then within here, every AUR package actually doesn't include any of the files. It just includes these definition files, including package build, which is the one that we need. This within it will tell the system where to actually get the files from, probably GitHub or GitLab. So we do make pkg, and then we just pretend we're Italian and we're saying yes. That's how I remember this command. And go. Done. Okay, great. So now if we just run Yay on its own, that is essentially the same as doing a pacman SYU, but it also checks the AUR for any updates. Speaking of which, let's install an app for the AUR. Oh, look, it's TizzyFetch. Why don't you go and watch my first video about how I made TizzyFetch? It's really interesting. So yeah, in this case, all it's doing is getting the type. Like it's a lot of fuss over the fact that it's basically grabbing one shell script and moving it to a bin folder. TizzyFetch. There we go. Woohoo! All right. Last job. We enable the LightDM display manager. Stupid name for them, by the way. Display manager. It really doesn't describe what they are. Sudo system enable. This will just mean that it runs, for God's sakes. Apologies. Systemctl enable LightDM. This just means every time it loads it in, it will enable it, which means it will fire it up, and we don't have to deal with the TTY. It will basically do this. So as soon as we press enter, you will see a login screen. Apologies if it's a bit small. We log in, and very soon we should hopefully see the mouse. Or the rat. Is it a rat? It's a rat, isn't it? Look at those little whiskers. Now then, we do have some monitor shenanigans going on here that I really can't be bothered to sort out. So I'm going to switch to the the B roll, like shaky cam. Way. So look, here's the lovely laptop running XFCE. We are there. We are done. We've still got lots of things to set up. We've got a kernel to set up in part 2, and that's going to be a lot of fun. And then I will allow my child to have his laptop back. But thank you very much for joining me on this slightly chaotic install, and I will see you next time. Catch you later.